So friends, welcome back. We are going to have a continuation of our discussion which we had about the transportation model. We are going to discuss what was the limitation of the least cost method. So limitation of this particular model is we have not considered the opportunity cost. We have considered the cost, but we have not considered what if I am not going to make allocation on this particular cost, then how my choices are going to get differ. Will my choice get differ if I not allocate on this and I put onto other thing? That what is the cost of next best possible alternative? That's opportunity cost concept was missing. So to remove that limitation, we are going to have another model which is called Vogel approximation model. So friends, I have taken once again the same example which we were doing. So in this particular example, now what this model says is Vogel approximation model says we need to calculate the opportunity cost, or in other words opportunity loss which we are going to have, that in other words we name it as a penalty cost. So we are going to calculate the first penalty, that what is minimum in this particular cost, that is a cost is 3. So that is where we should transfer, but in this particular row if I look at what was the next best was 4. So if I don't give it this 3, so what is the cost? So opportunity which I am going to lose for 4 minus 3, the loss I am going to have per unit is 1. And same way for the next, if I calculate again in the next line, I have seen what is minimum, that is 4, and 3, that is again coming 1, and same way here is coming 2, and same process we are going to repeat onto the column side. In the column side what we are going to see, again what is minimum is 5, what is the next highest is 8. So difference of this is penalty 1 is 3 here. Now interestingly both of the costs are same, that is 4 and 4. So there is no penalty available to me, so there is no loss. Same way on this also, minimum is 3, next highest is 3, so again 0 penalty. So from these penalties we are going to check which penalty is having a maximum loss. So maximum loss here is at this particular one is 3, and here on this was 2. So this is the maximum loss which I am going to have. So I want to avoid this maximum loss. So if I want to avoid this maximum loss, so why this loss is there? Because I am not making allocation here. So let me allocate here so that I can avoid my maximum loss. So this here, how much allocation I can make? Here is 100, here is 300. So I can allocate 100. This remains 200. This becomes 0, and now I move forward, that I will calculate another penalty, that is P2, and this becomes this becomes 0, so I cross this particular thing. So on this particular thing, in this particular row I am not going to have any kind of calculation, and now next penalty here is 1 again remaining that, and same is going to be here as 2, but here is going to be a change now. What is P2? Here is going to be 8 and 9, that is difference is 1. Here 4 and 7, difference is of 3, here is of 2. So what is the maximum penalty available from these two is this particular one. So I'll take this one, and why this penalty? This is because of this particular 4. So let me give some allocation here, that becomes 200. So this gives 0, this remains 100, and same way I'm going to have, now this becomes 0. So again I'll cross this particular section, I go to the third penalty. If I'm going to, now I'm not going to have for this particular section, but here is now 8 and 3, this is 3 is the cost, and this is 5, so difference is 5, so I'm writing penalty of 5, and here penalty of 4, that because 5 and 9, so that difference is 4, so I'm writing that, and then in the P3 there is again one penalty, no calculation, and here is 2. So out of these P3 penalties which we have, we will be checking what is the maximum penalty. Maximum penalty here is 5, and why this is so? Because 3 is not being allocated any cost. So let me give some allocation. How much allocation I can give? I can give allocation of 100 here. So remaining here will be 100. This becomes 0, and now this becomes 0. So I'll cross this particular thing. So I left with only 9 and 7. So I no need to calculate, because on one side I will able to calculate, but on other side I am not able to calculate penalty. So no need to do calculation for penalties now. So what is there max, I can give minimum out of this is this, how much I can give is give 100, so this becomes 0, remaining here is 200 and this remaining 200 will be transferred at this particular cost. So you can see with this new model, Vogel approximation model, I am able to reduce my total cost to 3900, which was originally in the northwest corner method we had 4200. So friends, now whether this solution which we have obtained is a best solution or not, that we have to test. So to test this, we have a modified distribution method, but before applying modified distribution method, we need to have a test whether it is able to solvable for the Modi method or not. That means we have to test the test of degeneracy. Now what is test of degeneracy? Test of degeneracy is called when you have number of items which we have allocated should equal to m plus n minus 1. M is number of rows and n is number of columns. So we have 3 rows and we have 3 columns, n minus 1, and number of allocation which we have, we can count 1, 2, 3, 4, 5. So I have 5 number of allocation, that is 5 is equal to 5. If it is getting satisfied, it means no problem, that my problem is not a degenerated problem. So it means I can go ahead with the modified distribution method. For applying modified distribution method, what I am going to write, I am going to make a same size matrix which we had, which will I will just put it in a smaller version so that we can have a easy and quick calculation. So what I am going to write in this particular thing, particular matrix, what are the cost of allocated cell. The cells where I have made allocation, this becomes 5, this becomes 4, 3, 9 and 5. So I will see which one is having a highest number of allocation. So that is this 2 are, and is this 2 are also, this 2 are also, this 2 also. So I have all 3 options available. So I name these cells as now U1, U2, U3. I am just naming it V1, V2. You may name anything, no problem. So I name it as U1, U2, you may X1, X2, Y1, Y2, no problem. So I am going to write what cell will be having a, I should start with. So I will start with where maximum number of allocations are there. So I say allocation will be done where this becomes value is 0. I assume one of cell value equal to 0 so that I can calculate the value for others. And one thing which you need to remember now friends, that Ui plus Vj is equal to the cost of particular cell, cost Dij or Cij. That means this inner cell cost is equal to if I am saying for this particular cell 5 is equal to what will be the value of U1 plus V1. Same way if I am saying this particular cell, the 4 is equal to U2 plus V2. Same way U3 is equal to U3 plus this V3 is equal to 5. So that is what I am going to check. Now with this checking, what I am having is, if I have this particular cell 0 and this is 3, how this will be 3? Because if V3 will be 3 and V2 will be 4, then it becomes 0 in this way. And same way I am going to have for the now other cells. Now if this is 3, I can have this will be 2 and 2 plus 3 will making it 5. And same way if I have this particular cell now, this is 2, so can I have the value of this? This value will be 7, and if it is 7, the value of this would be minus 2, because minus 2 plus 7 that makes it 5. Now I am going to calculate from this table I am going to derive the another values for the remaining cells the same by using the same logic. So by using the same logic, this is minus 2 plus 2. So what is the value of this particular cell? This will become 2, and this is 3 minus 2, that value becomes 1, and same way for this cell this will become 7, and for this cell it will become 6. So now we are going to, from this table we are going to check whether solution which we have obtained is the best one or not, and whether this derived values, the opportunity cost which we of not allocating is equal to the cost or not. So that we are going to check, which this particular calculation is known as net worth calculation, or as well as you can say net evaluation. So how we are going to net evaluate? So we are going to take the original table. The original table is going to show me what was the real original value, and these are the derived value. So I'll deduct from the original value the derived value, and that is called Cij is the original value, Dij is this value. So I'm going to deduct these values and going to check what values are going to come. So from the original table value is 4 and here is 2, so that becomes 2, and from in the original table the value was 8, here is 1, and difference is 7, so the difference is 1, and same way for this particular cell if I calculate 7 minus 6 is 1. So you can see here, and for this particular cell which was left here, that is 3 minus 1, that is 2. So we can see here all the values are positive. So if all values are positive, then we will say solution which we have obtained is the best solution, and because none of the value is negative means I have not done any kind of wrong calculation. My calculations are, my solution which we obtained, that is 3900 is the best solution which we have obtained. Thank you very much.